August 7th, 1944. 3 kilometers south of Mortagne, France. The pre-dawn silence of the Normandy countryside was not broken by the familiar rattle of machine gun fire, but by a concussive blast that felt less like a tank shell and more like a seismic event. Oberstleutnant Klaus Richter, commanding a seasoned platoon of Panther tanks from the 2nd SS Panzer Division, Das Reich, watched through his optics as the laws of armored warfare were violently rewritten before his eyes. What emerged from the morning mist rolling off the Norman hedgerows was a shape that defied every classification in the Wehrmacht's intelligence manuals. It possessed no sloping armor, no heavy tracks, and no camouflage netting. It was a farmer's tractor, an American John Deere Model D, moving at a glacial 15 miles per hour across the open field. But mounted on its reinforced chassis was a weapon that had no business on a European battlefield, a 5-inch 38 caliber naval cannon, the primary armament of U.S. Navy destroyers designed to hunt U-boats in the Atlantic. The sheer absurdity of the image lasted exactly 4 seconds. Then, the tractor fired. A naval round, engineered to breach the pressure hulls of submarines at ranges of 10,000 yards, struck Richter's lead Panther at a point-blank range of 400 meters. The result was not merely a penetration, it was total structural disintegration. The 44-ton German tank, a pinnacle of automotive engineering, ceased to exist as a fighting unit. Its 11-ton turret was severed from the hull and thrown 30 meters through the air like a discarded toy. The crew of 5 was vaporized instantly. What Richter witnessed in that terrifying moment was not just a new weapon, but the manifestation of the United States' most dangerous capability: the ruthless application of industrial asymmetry. This was the gun motor carriage M12, known to the terrified German infantry as the Devil Tractor. It represented a collision between German perfectionism and American pragmatism, born from a desperate intersection of agricultural ingenuity and naval surplus. To understand how a piece of farm equipment became the most feared tank destroyer of the Western Front, we must look beyond the battlefield and into the macroeconomic machinery of the American war effort. The story begins 6 months earlier, not in a war room, but in the industrial sprawling complex of the Philadelphia Naval Shipyard. By January 1944, the United States had achieved a level of industrial output that was creating its own unique logistical problems. The shipyard had stockpiled over 800 surplus Mark 12 naval guns. These massive weapons, each weighing over 6,000 pounds, represented $30 million in manufacturing capacity, roughly $500 million in today's currency, sitting idle. The Navy was shifting to newer 5-inch 54 caliber systems, leaving this massive arsenal in bureaucratic purgatory. They were too valuable to scrap, too heavy to store indefinitely, and legally restricted from export. This surplus crisis highlighted a critical aspect of the Allied economic advantage. While Germany struggled to produce enough barrels for their tanks, America was drowning in high-caliber excess. Captain Thomas Morton of the Navy's Bureau of Ordnance found himself facing this logistical nightmare. In a meeting that would alter the trajectory of the ground war in Europe, Morton met with Army Ordnance Liaison Major Robert Henderson. The conversation was intended to be a routine inventory review, but it evolved into a radical experiment in cross-branch resource allocation. Morton jokingly suggested the Army mount the naval guns on jeeps. Henderson, however, did not laugh. The Army's tank destroyer force, established under Lieutenant General Andrew Davis Bruce, was facing a tactical crisis. The existing M10 Wolverine and M18 Hellcat were effective, but the doctrine of 1944 demanded a weapon that could be deployed rapidly to counter the increasingly heavy German armor appearing in France. Henderson realized that the ballistic profile of the naval gun offered a solution that no purpose-built army weapon could match. The mathematics were terrifyingly simple. A 5-inch shell fired at 2,600 feet per second generated kinetic energy that exceeded any tank gun in existence. It could punch through 170 millimeters of steel at battle ranges, rendering the frontal armor of the fearsome German Panther obsolete. The engineering challenge was immense. A naval mount weighed over 20,000 pounds, a mass that would crush a standard truck chassis and immobilize a standard tank suspension. Developing a purpose-built tracked vehicle to carry such a weapon would require 12 to 18 months of R&D, time the Allies did not have as the invasion of Fortress Europe loomed. Henderson needed an immediate, off-the-shelf solution that could handle massive torque and weight. The answer came from the heartland of American civilian industry. John Whitaker, a civilian engineer from Moline, Illinois, who had spent 2 decades designing heavy agricultural machinery for Deere and Company, was brought in by the War Production Board. When presented with the problem of mobilizing a 3-ton naval gun, Whitaker's response was immediate and counterintuitive. Use a tractor. To the military mind, the proposal was insanity. Tractors were slow, unarmored, and designed for soil, not shrapnel. But Whitaker argued from a standpoint of industrial logistics rather than military tradition. The John Deere Model D had been America's best-selling tractor since 1923. It featured a frame reinforced for extreme drag loads and a 2-cylinder engine that produced massive low-end torque. Crucially, from a strategic supply chain perspective, there were over 160,000 of these units already distributed across the continental United States. Parts were standardized, and mechanics in every small town knew how to fix them. This was the genius of the American war machine, the ability to weaponize the civilian economy instantly. On February 14, 1944, at the Aberdeen Proving Ground, the prototype was assembled. It was a Frankenstein's monster of logistics, a used tractor bought for $350 from an Iowa farmer, mated to a $37,000 naval gun, stabilized by a hydraulic recoil system adapted from captured German anti-tank weaponry. The total conversion cost was a mere $1,200. When the first test round was fired, engineering officers braced for catastrophe, expecting the recoil to flip the vehicle or shear the chassis. Instead, the tractor slid backward 6 feet, the hydraulics hissed, and the gun cycled perfectly. In that moment, the M12 ceased to be an experiment and became a strategic imperative. Colonel James Morrison, commanding the test division at Aberdeen, stared at the smoking barrel of the naval gun and the intact chassis of the John Deere tractor. The physics suggested the vehicle should have flipped. The engineering principles dictated the frame should have sheared. Yet, the machine sat motionless, ready for the next round. Morrison's subsequent report to Army Ground Forces headquarters was a masterclass in military brevity. The system works. It shouldn't, but it does. Recommend immediate production. This recommendation triggered one of the most rapid industrial mobilizations of the war. By March 1, 1944, the M12 entered emergency production status. The Army ordered 500 units to be ready before the invasion of France, a timeline that would be impossible for a conventional vehicle, but was achievable for this hybrid monstrosity. What followed was a demonstration of American industrial capacity at its most terrifyingly creative. This wasn't just manufacturing. It was the weaponization of the civilian supply chain. While German industry was being systematically dismantled by Allied strategic bombing, relying on increasingly centralized and vulnerable production hubs. The M12 program decentralized the process across the American Midwest. Deere and Company factories in Moline, Illinois, and Waterloo, Iowa, did not retool for war. They simply continued doing what they did best: mass-producing Model D tractors. These units were then shipped to conversion facilities at Rock Island Arsenal. There, a workforce composed largely of civilians, many of them women filling the gaps left by drafted men, executed the conversion. The logistics were a symphony of efficiency. Naval guns arrived by rail from Philadelphia, 3 per freight car. Recoil systems were shipped from Detroit. Minimal armor plating was fabricated in Gary, Indiana. All these components converged at Rock Island, where the assembly process was streamlined to a shocking 16 hours per vehicle. By May 1944, production had hit 14 Devil tractors per day. The workforce, fully aware they were building the vanguard for the European invasion, operated on 12-hour shifts, 6 days a week. Quality control was fanatical. Every hydraulic system was pressure tested, and every tractor engine was run for 4 hours under load. This was the economic lethality of the United States. The ability to deliver a functioning, heavy-caliber weapon system faster than the enemy could transport raw steel to their own factories. The specifications of the finalized M12 Gun Motor Carriage were a study in contradictions. It weighed 8,400 pounds combat-loaded, lightweight compared to the 60,000-pound Sherman tank. Its maximum speed was a pedestrian 15 miles per hour on roads and a crawling 8 miles per hour cross-country. Protection was virtually non-existent. A mere 12 millimeters of steel plate on the front offered safety only against small arms fire and shrapnel. A heavy machine gun or a nearby mortar hit would neutralize the vehicle instantly. But the M12 was never designed to survive a hit. It was designed to ensure the enemy never got the chance to fire back. The primary armament changed the calculus of ground engagements completely. The 5-inch 38 caliber gun carried a mixed loadout of 30 rounds. 20 were armor-piercing Mark 14 naval rounds, designed to punch through submarine pressure hulls, which meant they could slice through German steel like a hot knife through butter. 8 were high-explosive Mark 15 rounds, originally intended for surface ships, which created blast effects capable of leveling multi-story buildings. 2 white phosphorus rounds were carried for target marking. This loadout gave the M12 a dual-threat capability. It was a sniper rifle against tanks and a sledgehammer against fortifications. The first operational units arrived in England on June 2, 1944, just 96 hours before D-Day. The 617th Tank Destroyer Battalion received 36 of these vehicles at a depot near Southampton. The battalion commander, Lieutenant Colonel Walter Abrams, was a former farmer from Nebraska. His reaction upon inspecting his new command was recorded in the battalion diary, capturing the incredulity of the moment. "They sent us tractors with naval guns. Either someone in Washington has a sense of humor, or we're about to change how anti-tank warfare works." Abrams, however, understood the machinery. He knew the reliability of the John Deere engine and the stability of the platform, but the tactical doctrine had to be invented from scratch. The M12 could not be used like the M18 Hellcat, which relied on speed to flank opponents, nor like the M10 Wolverine, which could trade blows in a hull-down position. The M12 was a glass cannon. Its survival depended entirely on 3 new principles: pre-positioning in concealed locations, achieving a first-shot kill at medium range, and immediate displacement. This was shoot and scoot taken to its logical extreme. The training schedule was accelerated to an emergency pace. The crews, a mix of artillerymen and tank destroyer personnel, had to unlearn standard Army gunnery and adopt naval fire control methods. Naval doctrine emphasized rapid target acquisition and a high volume of fire. Crews were trained to identify a target, engage within 10 seconds, fire 3 rounds in 30 seconds, and then displace to a secondary position before the enemy could triangulate the source of the shot. The hydraulic recoil system, designed for the rolling decks of destroyers, allowed for a sustained rate of fire that exceeded any purpose-built tank destroyer in the Army's inventory. This fusion of naval firepower and agricultural mobility created a unique tactical profile. The M12 was not an offensive breakthrough weapon. It was an ambush predator. As the invasion fleet prepared to cross the Channel, the men of the 617th painted their tractors in olive drab, covering the bright industrial colors of the farm. They were about to take a piece of the American Corn Belt into the hedgerows of Normandy, pitting the logic of mass production against the elite armor of the Third Reich. The German Wehrmacht, obsessed with technological superiority and heavy armor, had prepared for Shermans, Churchills, and Cromwells. They had absolutely no contingency plan for a John Deere tractor mounting a destroyer's main gun. On June 9, 1944, D-Day +3, the 617th Tank Destroyer Battalion rolled off the landing ship tank LST ramps and onto the scarred sands of Omaha Beach. The initial German resistance had been suppressed, but the beachhead was a chaotic symphony of logistics. Amidst the columns of mighty Sherman tanks, half-tracks, and deuce-and-a-half trucks, the arrival of 36 John Deere tractors mounting naval cannons presented a surreal tableau. To the beachmasters directing traffic, they looked like a logistical error. To the crews of the 617th, they were the difference between life and death. As they moved inland, leaving the coastal dunes for the Norman interior, they entered a battlefield environment that seemed almost preordained for their strange machines. The bocage. The Norman hedgerows were not merely bushes. They were ancient earthen fortifications, centuries old, with root systems as dense as concrete and vegetation thick enough to hide a platoon. For a standard tank like the Sherman, the bocage was a nightmare. To fire, a tank had to crest the embankment, exposing its thin underbelly armor to German anti-tank teams. But for the M12 Devil tractor, the bocage was a natural fortress. The vehicle's low profile, dictated by its agricultural lineage, allowed it to tuck perfectly into the vegetation. More importantly, its silhouette was organic to the landscape. In the peripheral vision of a stressed German scanner, an M12 looked like abandoned farm equipment, a piece of the background scenery, not a threat. This accidental camouflage, a psychological blind spot in German threat identification, would prove lethal. The theoretical capabilities of the M12 were put to the ultimate test on June 12th, near Carrington. The town was a critical junction linking the Utah and Omaha beachheads, and the Germans knew it. A counterattack force from the 17th SS Panzer Grenadier Division Götz von Berlichingen, a unit hardened by years of brutal combat on the Eastern Front, was moving to silver the American lines. They deployed a heavy reconnaissance force consisting of 15 Panzer IV tanks and 8 SUG-3 assault guns, advancing in column formation along the Carentan-Perriers Highway. They expected to encounter American infantry or perhaps light Stuart tanks. They were prepared for conventional warfare. They were not prepared for Staff Sergeant Raymond Mitchell. Mitchell had positioned his M12 in a dense hedgerow overlooking a curve in the highway at a range of 350 meters. It was a textbook ambush position, offering a clear line of sight while masking the vehicle's distinct lack of armor. His gunner, Corporal James O'Brien, a former Boston shipyard worker who understood the eccentricities of naval ballistics, tracked the lead Panzer IV. In a conventional tank engagement, the gunner would aim for the center of mass. But O'Brien knew the 5-inch shell had a trajectory flatter than any Army gun. He aimed for the turret ring. When Mitchell gave the order to fire, the physics of the engagement shifted from ground combat to naval devastation. The 55-pound armor-piercing shell left the barrel at 2,600 feet per second. It crossed the 350-meter gap in less than half a second. The round struck the Panzerwaffe's turret roof at a slight downward angle. The kinetic energy transfer was catastrophic. A standard anti-tank round punches a hole. A naval round, designed to breach the pressure hulls of submarines, acts like a sledgehammer hitting a watermelon. The shell penetrated the 50-millimeter armor plate, but the devastation didn't stop there. The high-explosive filler, fused to detonate after penetration, triggered inside the fighting compartment. The explosion was so violent that witnesses reported the Panzer's engine block, a massive piece of cast iron situated at the rear of the tank, was launched 30 feet into the air. The internal overpressure was so extreme that the welds of the hull failed simultaneously. O'Brien didn't hesitate. Adhering strictly to the naval rapid-fire doctrine, he fired 7 more rounds in 90 seconds. The hydraulic recoil system, hissing rhythmically, kept the gun on target. By the time the minute-and-a-half engagement ended, 3 more Panzer IVs and 2 Stug-3 assault guns were burning wrecks. Then came the second phase of the M12 doctrine: displacement. Before the stunned German column could identify the source of the fire, Mitchell ordered the driver to reverse. The tractor, with its high-torque, low-gear transmission, backed out of the hedgerow and repositioned 200 meters south. When the surviving German tanks finally rotated their turrets toward the smoke of the initial firing position, they were pounding an empty bush. Meanwhile, the Devil tractor was already setting up a new ambush angle. The after-action report from the 17th SS Panzer Grenadier Division regarding this engagement, later recovered by Allied intelligence, reveals a breakdown in command and control triggered by sheer confusion. The German commander wrote, "Encountered unknown enemy anti-tank weapon of extreme penetration capability. Vehicle type unidentified. Appears to be civilian tractor mounting heavy caliber naval gun. 8 tanks destroyed in under 2 minutes. Weapon withdraws and repositions with agricultural vehicle speed cannot be effectively countered with standard tactics." This report highlights a critical strategic failure on the German side: the inability to process asymmetric threats. The Wehrmacht's doctrine was rigid, built on the assumption that high-value assets like heavy guns would be mounted on high-value chassis. The concept that the Americans would bolt a destroyer-class weapon onto a disposable farm tractor didn't exist in their tactical playbook. This cognitive gap was deadly. German reconnaissance units routinely glossed over M12 positions, logging them as abandoned machinery, only for those machines to open fire moments later. News of the Teufelstractor, the Devil tractor, spread through the German lines with the viral speed of a battlefield rumor. It created a specific psychological terror. Being killed by a tank was war. Being killed by farm equipment was a horror story. Obergrenadier Hans Müller, captured near St. Lo in July, told interrogators, "They looked harmless, like farm equipment left in the fields. Then they would fire, and our tanks would explode." The sound was different from other American guns, deeper, more powerful, like thunder trapped in a box. We learned to fear any tractor we saw, but by then it was usually too late. The M12 had achieved something rare in warfare. It had become a psychological weapon as effective as its kinetic payload. By July 1944, The war in Normandy had devolved into a brutal battle of attrition centered around the strategic crossroads of St-Lô. This was the crucible where the M12 Devil tractor transitioned from an experimental oddity to the linchpin of American defensive doctrine. The 617th Tank Destroyer Battalion, now reinforced to a full strength of 48 vehicles, was deployed in depth throughout the labyrinthine hedgerow country surrounding the city. Here, the M12's lack of armor became irrelevant, and its ability to vanish became decisive. The German Wehrmacht, attempting to reinforce the crumbling defenses of St-Lô, found themselves advancing into kill zones that were invisible until the moment of detonation. The tactical reality was simple yet devastating. German forces had to move to attack, while the M12s simply had to wait. The definitive demonstration of this defensive supremacy occurred on July 18th. The Panzer Lehr Division, widely considered the elite armored formation of the German military, launched a desperate counteroffensive north of St-Lô. They committed their operational reserve, 63 Panther tanks and 38 Panzer IVs, advancing in a coordinated keel, wedge formation, designed to shatter American lines through sheer mass and superior armor. Against conventional anti-tank guns, this tactic might have succeeded. But they were not facing conventional guns. They were walking into a trap set by Lieutenant Robert Jameson, who commanded a platoon of 4 Devil tractors positioned along a narrow 1,200-meter frontage. Jameson's after-action report describes the engagement with a clinical precision that belies the violence of the moment. He allowed the German column to close to within 200 meters, a suicidal range for any other vehicle, but necessary to ensure a 100% hit probability. When his platoon opened fire, the effect was instantaneous. The first salvo destroyed 3 Panthers simultaneously. The naval rounds didn't just penetrate, they shattered the cohesion of the German formation. As the surviving German tanks frantically rotated their turrets to return fire, Jameson's units had already executed their displacement drill, reversing into deep cover. When the Germans fired back, they were suppressing empty hedgerows. Jameson's platoon re-engaged from alternate positions at 300 meters, destroying 5 additional Panthers and 2 Panzer IVs before the German attack lost all tactical cohesion. In 14 minutes, the Panzer Lehr lost 40% of its committed armor. Friendly casualties were 0. The Panzer Lehr Division's war diary recorded this engagement with a tone of barely concealed despair. The entry read, "Encountered concentrated enemy anti-tank defenses of unprecedented lethality. Weapons believed to be heavy naval guns mounted on tracked platforms. Penetration capability exceeds all known anti-tank weapons. Cannot effectively engage due to weapons' rapid displacement capability. Attack suspended. Recommend immediate withdrawal." This entry highlights the ballistic overmatch the M12 enjoyed. Standard tank rounds rely on kinetic energy to punch a hole. The 5-inch naval round, however, was a semi-armor-piercing, high-explosive hybrid. It combined the kinetic punch to penetrate the armor with a massive explosive filler designed to gut a ship. When this detonated inside the confined space of a tank, it didn't just kill the crew. It caused catastrophic structural failure. Panthers struck by M12 fire frequently suffered turret separation. The violence of the internal explosion literally blowing the turret off the hull ring. By August, as the Allies began their breakout, German intelligence had compiled a comprehensive dossier on the M12, which was forwarded to Panzer Group West headquarters. This document reveals the dawn of a new strategic anxiety among the German High Command. The report detailed the weapon's characteristics: a rate of fire of 4 rounds per minute, penetration exceeding 170 millimeters, and a reliance on civilian chassis. But the conclusion of the report was prophetic. It warned, "The M12 represents a category of American weapon development we cannot match. The conversion of civilian industrial capacity to military application with minimal modification. The enemy possesses thousands of agricultural tractors. They possess thousands of surplus naval guns. If they choose to produce M12 units at scale, our armored forces will face weapons against which we have no effective counter." This intelligence assessment struck at the heart of the Axis strategic dilemma. Germany was fighting a war of specialized engineering, where every weapon was a bespoke creation requiring intricate manufacturing. The Panther tank was a masterpiece of engineering, but it cost 117,000 Reichsmarks and took thousands of man-hours to build. The M12 was a piece of farm equipment with a recycled gun. The Germans realized that the Americans weren't just beating them with better tactics. They were beating them with a superior economic philosophy. The M12 proved that a good enough platform produced in massive numbers, carrying a superior weapon, would always defeat a small number of perfect platforms. The prediction of mass proliferation proved accurate. By September 1944, Rock Island Arsenal had ramped production to 22 units daily, with a total of 873 M12 delivered. The Army formed 12 additional dedicated tank destroyer battalions equipped exclusively with Devil tractors. This success triggered a wave of similar improvisations across the Allied forces. The Navy began mounting 5-inch guns on Sherman chassis, the M40, and the British began adapting their own naval reserves. But it was the M12 that led the charge during Operation Cobra, the breakout from Normandy. Here, the M12 demonstrated remarkable versatility, shifting from a defensive ambush predator to an offensive support weapon. As American infantry and armor raced across France, M12 units were assigned to follow the initial assault waves. Their mission was to secure captured towns against the inevitable German counterattacks. The M12's slow speed, previously a liability, became an asset in this phase. They didn't need to race the tanks. They needed to arrive, tuck themselves into the rubble of a liberated village, and turn it into an impregnable fortress. During the first 48 hours of Cobra, M12 units destroyed 117 confirmed German tanks while losing only 9 vehicles, an exchange ratio exceeding 12-1. The advance to the port city of Brest further expanded the M12's legend. Brest was heavily fortified, a network of concrete bunkers and pillboxes that had resisted weeks of aerial bombardment. Conventional tank guns bounced off the thick, reinforced concrete. But the M12 was armed with a weapon designed to fight battleships. Using high-explosive naval rounds, the Devil tractors engaged German bunkers at point-blank range. The shells, weighing 55 pounds, could penetrate 2 feet of concrete before detonating. Major General Troy Middleton, commanding the 8th Corps, noted in his official report, "The M12 Gun Motor Carriage has proven invaluable in reducing fortified positions. Naval high-explosive rounds achieve effects that would otherwise require heavy artillery or air support." The tractor had become a siege engine. As the Allied armies pressed against the German border in the autumn of 1944, the nature of the war shifted once again. The open fields of France gave way to the dense forests of the Ardennes and the urban ruin of the Reich itself. This change in terrain set the stage for the M12's most grueling test, the Battle of the Bulge. When Hitler launched his final major offensive on December 16th, the weather neutralized Allied air superiority, grounding the fighter bombers that had terrorized German armor. For the first time in months, the ground war would be decided solely by the weapons on the field. In the freezing fog of the Ardennes, the Devil tractor ceased to be a hunter and became a linchpin of desperate defense. The 617th Tank Destroyer Battalion, holding the line near Bastogne, found themselves in a nightmare scenario. Visibility was less than 200 meters. German armor was advancing in overwhelming numbers, expecting to roll over disorganized infantry. Instead, they ran into Sergeant First Class Michael O'Malley and his M12, dug into the rubble of a destroyed building in the village of Longvilly. O'Malley's crew had turned their tractor into a static pillbox, reinforcing the position with debris. When a German Panther emerged from the fog at a mere 75 meters, O'Malley's gunner, Corporal Stephen Blake, fired. At this suicidal range, the ballistics of the naval gun defied belief. The shell didn't just penetrate the Panther's glacis plate. The kinetic energy was so extreme that it punched completely through the tank, exited the rear armor, and demolished a brick wall 100 meters further down the street. Blake fired 11 rounds in 3 minutes, destroying 6 Panthers. The German assault collapsed not because of superior numbers, but because a single tractor with a battleship gun had created a localized zone of absolute destruction. As the Allies pushed into Germany in early 1945, the M12 evolved again, this time into an urban siege weapon. In the streets of Cologne and the bridgehead at Remagen, the M12's ability to shoot and scoot became vital in city fighting. Crews would position the tractors inside the ground floors of captured buildings, firing through blown-out windows. The naval high-explosive rounds, designed to wreck ship superstructures, brought down entire building facades, burying German snipers and anti-tank teams in rubble. When the 9th Armored Division captured the Ludendorff Bridge at Remagen intact, it was the M12 battalions that rushed across to the eastern bank. General Major Otto Hitzfeld, tasked with destroying the bridgehead, reported that his counterattacks were being shattered by heavy-caliber weapons that he couldn't suppress with artillery. He was being stopped by farm equipment. Production continued until May 1945, 1 week after the German surrender. The final tally stood at 1,417 units produced over 13 months. The total cost of the M12 program, including research, development, and production, was $18.6 million. By comparison, the M10 Wolverine program cost $137 million. The M12 delivered comparable lethality at roughly 1/10 the cost per unit. This economic disparity encapsulates the true reason for the Allied victory. The United States didn't just outfight the Axis, it outspent and outproduced them with a ruthlessly efficient allocation of resources. The M12 was the physical embodiment of total war economics. Nothing was wasted, everything was weaponized, and cost efficiency was as lethal as high explosives. In the immediate aftermath of the war, the fate of the Devil tractors mirrored the pragmatic spirit of their creation. Approximately 600 units remained in Europe. They were not preserved as monuments. They were recycled. The naval guns were removed and scrapped or returned to Navy storage. The chassis, still functioning John Deere Model D tractors, were sold to French and Belgian farmers for pennies on the dollar to help rebuild the continent's agriculture. It is a profound historical irony that the very machines which had destroyed Panther tanks in the hedgerows of Normandy spent the next 20 years plowing those same fields to feed a recovering Europe. Swords were literally beaten back into plowshares. Today, only a handful of M12 survive in museums, including one at the Aberdeen Proving Ground. They stand as silent testaments to a pivotal divergence in military philosophy. The German approach to war was one of engineering perfectionism. The belief that the superior machine, the Panther or the Tiger, would triumph through quality. The American approach, symbolized by the M12, was one of industrial pragmatism. The belief that the solution that works now, produced in overwhelming numbers, beats the perfect solution that arrives too late. The legacy of the gun motor carriage M12 is not found in the fame of the Sherman or the glory of the P-51. It is found in the deeper, grittier reality of how the Second World War was actually won. It was won by a nation that looked at a surplus of naval guns and a surplus of tractors and asked, "What happens if we combine them?" It was won by the farmers who drove them, the women who built them, and the commanders who dared to deploy them. The Devil tractor proved that in the crucible of global conflict, the most dangerous weapon is not always the most sophisticated technology. It is the unrestricted imagination of a free people backed by the relentless engine of industrial democracy. When a farmer's tractor can kill a King Tiger tank, the outcome of the war is no longer in doubt.